So removing the fan from the printhead is not something new. The idea has been there for quite a while, and we've seen a couple set up already with Cpap tubing and all kind of different fans like radial fans, also turbo cooling fans. And I've also had a tried with that idea a couple months ago, 1 year ago, and I completely failed. As you can see on the screen right now, it's a bad design. I tried it, I failed. It was a bad idea, but I'm back again at it, and this time I have something that is really working good, and I want to share that with you guys. So let's just take a look at it and see what we got. All right, so there it is installed on the printer. As you can see, running the Cpap. Let me just open the top cover. And just if you're asking, this tube and the entire tube weighs about 17 gram. But the thing is, it's held on this side here, so about half of the weight is not moving. I would say maybe less when it's over here and the printhead moves like that. So I think I've lost a bit of weight on the printhead. The 5015 fan weighted 24 grams, and we're now at 17 grams with this tube. But again, it's not completely the weight is not completely all on the printhead because, yeah, it's suspended and it's held by this side. I'll show you some input results, input shaper results from the resonance test that I've done, and you'll see I've gained a bit of acceleration, and I've gained a bit of frequency. So that means it's lighter. I was also worried about not only the weight but the tube itself. It's super flexible, so I was worried that the force needed to move that tube around would be equal to the force that needs to move the fan around. But I don't think it matters a lot because it's super light, it's super flexible, it's really easy to move around, so I don't think this will be an issue. And if it is, it's going to be negligible. And from what you'll see on my input shaper, you'll see that it was actually a good thing. Now, you probably see this little guy here. This is the intake for the Cpap fan, which is running on the outside of the enclosure. However, I wanted to take the intake from the enclosure. And there's two major reasons for that. The first one being, when you print with ABS, you want the enclosure to stay at a certain temperature and keep that temperature stable. It's keeping the heat inside, and you want the warm temperature to stay there. If you blow air from outside to inside, you're going to cool down the enclosure, and we all know what's going to happen with your ABS print. It's going to crack, it's going to fail. The second thing is, and again, it's with ABS, but it's also valid for every other material like carbon fiber material or every material that is toxic. Even PLA is not good to breathe, even though, well, we all know about it. But yeah, so if we take air from the outside, bringing it inside, what's going to happen is that you're going to build up a pressure inside the enclosure because you're pushing air in. So air has to come out to compensate and to equalize the pressure. So that means it's going to leak everywhere. It's going to leak from the cracks from the doors, from the top cover, from every cracks that I have and little holes that are everywhere on the printer. And that's bad because ABS fume will be all over my room, and it's not healthy. So keeping the intake and keeping the air inside and keeping that pressure and temperature inside is the reason why I've done this little intake right here. So what else? Yeah, let's take a look at how it sounds. And before we go there, I just want to say that I've done some tests, and at equal flow between the 5015 and this Cpap turbo fan, when it pushes about the same amount of air, you'll be surprised that this guy is actually quieter than my overvolted 5015. And I was also surprised. So let's just take a look at it. I'm going to use this slider. The only downside here about this is that it only starts at around 17. So this is the minimum. This is the minimum cooling, and I think it's low enough to have no issue with ABS, cooling ABS, but it's probably half of no, not half. It's probably 25 to 30% power on a 5015, at least from my setup. So I think this is just minimum amount of cooling that will be very good to have. Now if we crank it up a bit, let's do 20. At 20, let's say, if I remember right, that was 23. So now it's about the same amount of cooling that I get from my old setup overvolted. I'm not too sure if you can hear that, but it's super quiet. It's very, very quiet. It's very nice because you don't, on most of part, you don't need super high intense cooling. But if you do need it, well, you can just throw more at it. So even at 37%, it's still decent for the noise. It's about equivalent to my other system, but it's about twice or more air cooling. But we cannot stop there. We can crank it up. That's 50%. That's 60. 75. 85. And full blast. And you saw that on the intro there. It was blowing so much air that the water got everywhere. It splashed everywhere. And don't worry, I know it was stupid. Water got everywhere, so no electronics were hurt. Nothing was broken, hopefully. So don't try this at home. If you try this setup, you already know it's blowing a lot of air. So don't try this. So now, I thought I would just share with you how I got this working with pulse width modulation, which is a very easy thing to do. There's a couple ways that you can do it, and we're going to discuss about that. But first of all, I'd like to give some credits to the guy that found this little Cpap fan turbo, and he's the first one that experimented with it. Even though the idea of remote cooling was already there, this fan was, well, I found another guy that did it a couple years ago, but it was not good like this. So thumbs up and credits to Olivier or Oliver at Hevort. He's the first one that has taken this fan, and he's shown this on his YouTube channel. I was like, wow, I need this. This is exactly what I need. And honestly, look at this. It looks awesome. I think it looks even better because it helps the sagging of this. It's just a good looking printer now. I like this a lot. So without wasting any more of your time, let's jump onto the computer and I'll show you a couple pictures in the back how we can wire it, how we gonna set up pulse width modulation to be able to control the power from your slicer and from clipper screen and for whatever from the slider from main cell. So let's take a look at it. All right, the wiring now, it is very simple, pretty straightforward. As you can see here, my recommendation here is to use one of the GPIO pin on the Raspberry Pi. Very simple way to do it. You just use one of your GPIO of your choice. In my case, I've used GPIO pin 26, which is 37 in the number of pin. And you directly connect that to the gray pin on the connector. And when you receive that Cpap fan, you'll see that the gray wire is the second from the left. So you're going to use that one and use for that PWM. The Raspberry Pi has a 3.3 volt output. The board wants a 5 volt PWM signal, but 3.3 volt is enough to trigger that. And I think from anywhere from like 2 volts to 5 volt, it's still going to work. And now the power supply for that board, just connect that to your 24 volt power supply. If you power up the Raspberry Pi with a external power supply, like a official Raspberry Pi power supply, just be careful because there's not going to be a shared ground between the Pi, your 3D printer board, and the Cpap controller board. So what you're going to have to do is to make sure that all grounds or DC grounds are connected together and they are shared. So I can show you that in this case pin 39 on the Raspberry Pi, you connect that to ground or to DC negative on your power supply, or anywhere on your 3D printer board that is a ground or something like that. So that will make sure that they all have the same reference ground for voltage. Otherwise, you might have issues. I've tried another way to connect that PWM using the 3D printer board output, a fan output on a 3D printer board. Just a quick note there, it works, but I prefer the Raspberry Pi. It gave me a better control over the power of that fan. If you use a 3D printer board, that's still going to work. However, there's a couple things you need to do simply because on the 3D printer board, the PWM signal triggers from the negative pin and not the 5-volt pin. So it means it's gonna pulse adds from 0 volt to 5 volt. So in Clipper, when you're going to define that pin, you need to reverse that logic by putting a exclamation mark in front of that pin. I'm going to show you that later in Clipper. So that way it's just reverse the logic and that's going to work. Now be careful. It's not all 3D printer board that can support 5-volt output for fan. Most modern 3D printer board have a selector for voltage from 5, 12, or 24. If you don't have that, just don't use it or use something else like a GPIO pin on the Raspberry Pi, because if you feed more than 5-volt, you're probably going to damage that board. Okay, that being said, let's just take into consideration in this case that we're going to use a Raspberry Pi GPIO, and that is my recommendation for now. Okay, now for the Clipper part, you're going to have to edit your printer configuration. The first thing you're going to need if you want to control that with the Raspberry Pi is to install the Clipper MCU on your Raspberry Pi, and that will act as a second 3D printer controller board. I'm not going to go into how you do this. I'm just going to put a link down in the description for how to install that, and that's going to be an easy way to control your Raspberry Pi. Now, let's go to the pin definition for that fan. Here it is. So, once you have the MCU installed, it's very easy to control the pins there, the GPIO pins. What you need to do is you normally set your pin like that, but in front of that GPIO pin, you need to call the MCU name and then a colon and then the GPIO pin number. Let's just go back up here. This is my Raspberry Pi definition as MCU, and I called it RPI. So every time you define a pin for the Raspberry Pi, that's how you're gonna reference that using that name here. As you can see, RPI is what I've chosen to use. It can be anything. It doesn't have to be RPI. You can call that Raspberry. Anything will work as long as you use the same word when you define a pin. So set the maximum power to 1, set the cycle time to 0.002, and if you look at the specs of that fan, it says 50 kilohertz, 50K, and that means 0.002. That will be its normal cycle time. It's the speed at which it's going to pulse the signal. However, I tried that, and it's just not going to work good. You're going to lose a lot of flexibility. It's going to start the fan way later, and you're going to lose the ability to run the fan at lower speed. I don't know why. I'm not a pro there, so I can't explain it, but I tested a lot of cycle time, and this is what I found was working best for me. So go ahead and use 500 kilohertz, 500 hertz, which is 1 divided by 500 will give you that value. You're going to have to disable hardware pulse width modulation because we're going to use software pulse width modulation. Normally, fans don't like hardware modulation, so just set that to false. And set the shutdown speed to 0. So that's going to tell Clipper to don't run the fan when the Clipper firmware is not running. However, I found for some reason that this is not going to work. For me at least. The fan, when Clipper starts, is going to be on by default, even though we've used a pin that is supposed to be off, and even though we've set the shutdown speed to 0, it's going to run at its minimum speed, which is not very loud. You don't hear that a lot, but it was annoying a bit for me. So I decided to use another pin on the 3D printer board, I've used the heater pin connected to a relay, and I instruct Clipper. Here it is. I instruct Clipper to just cut the power to that 24-volt supply on the Cpap controller board. So I feed the controller board not directly from my power supply, but I feed it from the heater port number 1 on my 3D printer board. I had extra port that I could use, and I've used that one. And I set the value to shut down 0. So there's not going to be any voltage to that board when Clipper starts. So the fan will be always off when Clipper is shut down, or when you do a kill switch, or when you just restart the firmware, it's still going to shut down the fan and not run at minimum speed. If you do it, just make sure you either use a MOSFET or a relay, and that way you're going to secure the board from a backfeed from that fan. So that's about it for Clipper definition. Now you're all ready to start testing and have some fun with that fan. Okay, so now that we're all set up, everything is installed, I've run some resonance tests with the accelerometer. And I was happy to see that the top graph, this is showing the X measurement. And as you can see, I've gained a couple Ks of acceleration, of recommended acceleration. And the frequency at which it resonates also gone up, which is always a good thing. It means we've reduced the weight on the printhead. And also the amplitude has gone down a bit. On the bottom graph, it was spiking at around 3.4, and now we're around 1.3. So that is a good thing. I still have that annoying spike at the end around 130 hertz, but it's the same on both graphs. It's spiking at around 0.8, 0.7. Maybe 0.6 or 7 on both sides. So this has not changed, but everything else has gone better. So it's a good thing. Now, if we take a look at the y-axis, on the y-axis, about the same thing that I've noticed. Frequency has gone up. I've gained a couple Ks of acceleration, of recommended acceleration, but also the amplitude of the vibration has gone down. And don't get fooled by this graph. Look at the scale on the left. We have 1 E4 on the Cpap and 1 E5 on the 5015. So it went down quite a bit. Not a lot, but it still went down. So everything is better with the Cpap setup. So that made me happy. This is a bit loud, but I'm printing at 400 millimeters per second in phase mode with PLA, and this is something I was never able to do before at that speed. Maximum I could get was like 200. Now it's doubling up, 400 millimeters per second, and it's absolutely gorgeous. It prints flawless, and yeah. Besides the noise, everything works super good. We also have the RSCS cooling system turned on. So it's a lot of cooling, but to go crazy like that, you need a lot of cooling. Let's take a look. That is awesome. Maybe I could lower it a bit. Maybe that's enough. I think it's enough, so it's a lot less noise. Maybe I could lower it down again. Let's give it a shot. That's 73%. And that's still looking good. I'm not sure we can go any more lower. Let's do 68. Now it's starting to sound better. That is a pleasant sound. It's not aggressive. And that still prints very good. At that speed, it's still a lot of cooling. Let's see if we can lower it down again. Let's go 60. Ah, now it's quiet. The sound that you hear here is not the Cpap now, it's the RSCS system. But I think it needs a bit more cooling than that. As you can see in the back, it starts to degrade. So let's go back to 70. Yep, now it's better. Oh, just for comparison, I'm gonna turn off the RSCS system right now. RSCS system is now shut down. It's a lot better, but I think it's gonna need more cooling. Definitely need more cooling. 80%. Yeah, see, at that speed, it needs the RSCS system because the cooling on the head itself is not enough because it doesn't stay long enough at the same spot. So you couple that with the RSCS system. I'm gonna turn it on. There you go. And you get a crazy amount of cooling for going crazy print speed. Haha. There you go. I'm super happy. It works super good. %. Let's try to crank the speed then. I don't know why I won't crank the speed. Oh, I set a maximum in my clipper. But anyway, I'm just gonna cancel this right now. And I'm gonna shut down all the fans so we can... There you go. All right. I'm super pleased with the result. It's, I mean, you can clearly see that there's issues when I reduce cooling, but other than that, when I go crazy with cooling, I can print super fast without issues. I couldn't do this before. That's very awesome. Anyway, now it's time to say goodbye. I hope you enjoyed it. I'm gonna put the CAD files of everything that you can print and reproduce that on your own printer. I'm gonna put that on my GitHub, so I'll put another link in the description. And that was it. So there you go, the Cpap cooling system. Pretty awesome to me. So on this, folks, I hope you enjoyed that video. It was a bit long and boring again. When you go technical stuff, it's just it takes a bit more time to explain and makes the video a bit more boring. But yeah, that was it, and that's a good one. Have a good night. See you on the next one.